Let's begin by understanding what a research question truly is. At its core, a research question is the specific inquiry that a research project or study sets out to answer. It acts as the guiding star for the entire research process, shaping the direction and focus of your work. Good research questions are typically narrow, specific, and designed to improve knowledge on an important topic. They aren't static either. Questions can evolve as researchers review literature and develop their theoretical framework. This dynamic nature ensures that the question remains relevant and meaningful throughout the research journey. Craft a strong research question. Many researchers use the funnel method. This approach starts with a broad topic, then narrows down as you gain working knowledge, develop preliminary questions, and finally arrive at a specific research question. Think of it as moving from a wide lens to sharp focus. Along the way, you'll encounter selection criteria like the FINER or PICO methods, which help ensure your question is both relevant and researchable. This structured approach keeps your research grounded and purposeful. Well-defined research question does more than just guide your study, it establishes its boundaries. By clearly stating what will and won't be explored, the question sets limits and ensures cohesion throughout the research process. This clarity is crucial as it prevents the study from becoming too broad or losing focus. The research question acts like a fence, keeping your investigation on track and making sure every step aligns with your original intent. Impact of a research question doesn't stop at defining boundaries. It creates a domino effect, influencing every aspect of your study, from the methodology you choose to the sample size and even the way you analyze your data. A clear, well-constructed question ensures that each part of your research is logically connected. This interconnectedness is what gives your study its strength and coherence, making your findings more reliable and meaningful. Quantitative research questions are all about precision. They include dependent and independent variables and are designed so they can't be answered with a simple yes or no. Instead, they aim to measure responses or describe variables within a population. Some questions are descriptive, focusing on how a group responds to certain variables, while others are relationship-based, exploring trends or associations between two or more variables. This specificity is what makes quantitative research so powerful for drawing clear, actionable conclusions. Contrast, qualitative research questions are flexible and open-ended. They often use words like explore or explain, allowing researchers to adapt as new insights emerge. These questions can be contextual, describing what exists, or evaluative, assessing the effectiveness of methods or interventions. Mixed method studies may combine both quantitative and qualitative questions, or use a single integrative question to bridge the two approaches. This adaptability makes qualitative research ideal for understanding complex, nuanced phenomena. Measurement is a cornerstone of research. It involves observing and recording data collected as part of your study. To measure effectively, it's important to understand the four major levels: nominal, ordinal, interval, and ratio. Each level offers a different way to categorize and interpret data, from simple nomming to precise numerical comparisons. Mastering these levels ensures your research findings are accurate and meaningful. Critical concepts in research measurement are validity and reliability. Construct validity refers to how well your study's operational definitions reflect the theoretical constructs you're investigating. Reliability, on the other hand, is about consistency, how repeatable your measurements are. While reliability can only be estimated, not calculated exactly, both concepts are essential for ensuring your research results are trustworthy and robust. Survey research is a popular method for collecting data. It involves asking questions of respondents, either through questionnaires or interviews. Designing a good survey requires careful decisions about question content, wording, response format, and sequence. The goal is to gather accurate, reliable information that directly addresses your research question. By mastering survey construction, you can ensure your data collection is both efficient and effective. Scaling is the process of associating qualitative constructs with quantitative metric units. Common unidimensional scales include Thurstone, Likert, and Gutman scales, each offering a unique way to measure attitudes or perceptions. Scaling allows researchers to quantify abstract concepts, making it easier to analyze and interpret data. This step is crucial for transforming subjective responses into meaningful, actionable insight. Hypothesis sits at the heart of the research process. It's an assumption built on evidence, serving as a foundation for future investigation. Hypotheses help researchers validate or disprove assumptions, reflecting their understanding of the problem statement. Writing a good hypothesis requires reviewing previous theories and academic papers, ensuring it's grounded in a rational framework. This step is essential for knowledge development and scientific progress. Write a strong hypothesis. Start by addressing the specific research question or problem statement. Use a three-dimensional phrase in the if, then format to clearly identify independent and dependent variables. Hypotheses can be non-directional, directional, or null depending on the relationship you expect to find. A good hypothesis is testable with clear variables and appropriate relationships, ensuring it can be validated through research. There are several types of hypotheses to consider. A simple hypothesis suggests a single independent variable affects a dependent variable. A complex hypothesis involves multiple independent and dependent variables. The null hypothesis assumes no relationship exists, while the alternative hypothesis posits the opposite. Simple hypotheses often establish a clear causal link, making them easier to test and interpret. Hypotheses can also be categorized by their nature. Logical hypotheses use reasoning to connect research and build theories with limited evidence. Empirical hypotheses or working hypotheses are tested systematically to prove or disprove their validity. Statistical hypotheses are based on data from a sample and involve hypothesis testing to assess the plausibility of a population parameter. Directional hypotheses specify the direction of a relationship, while non-directional ones simply indicate a difference exists. Hypothesis testing follows a structured process. First, determine the null hypothesis, then specify the alternative. Next, set the significance level, often 0.05, before calculating statistics and the p-value. Finally, draw conclusions based on your findings. The null and alternative hypotheses are mutually exclusive, meaning only one can be true. Test statistics and p-values help you decide whether to accept or reject the null hypothesis, ensuring your conclusions are data-driven. Hypothesis testing isn't just theoretical, it has real-world applications. In manufacturing, it's used for quality control, while in business, it helps evaluate strategies before implementation. Clinical trials rely on hypothesis testing to prove the efficacy of new drugs. For example, if a test statistic exceeds the rejection region, the null hypothesis is rejected, supporting the alternative. This process allows researchers to evaluate claims before making important decisions. Hypothesis testing offers significant benefits, such as allowing researchers to extrapolate data from a sample to a larger population. However, it also has limitations. Interpreting p-values can be tricky, especially with ambiguous stopping rules or multiple comparisons. Publication bias is another concern, as only statistically significant results may get published. A well-designed research plan acts as a blueprint, ensuring efficient data collection and analysis and maximizing the value of your study.